Hi friends, welcome to my YouTube channel. This video will be helpful for those who are writing competitive examinations and then those who are studying UG degree, PG degree, etc. In the previous video, I have explained about the intermediates which we come across in the organic chemistry. In this video, let us see about carbocations. These are the common reaction intermediates which we come across the organic mechanisms. These are carbocations, carbanions, free radicals, carbenes, nitrines and benzenes. In this first we will see about carbocations. Carbocations are formed by the heterolytic fission of a molecule. That is, I have given one example here. In this, X atom is more electronegative when compared to the carbon atom. So, it takes along with it the bonded pair of electrons as it outgoes as an anion and it produces a carbocation. So, see Beer's positive charge here and X becomes an anion. Now, let us see about the properties of carbocation. Carbocation bears positive charge, hence it is a positively charged species, and this carbocation is sp2 hybridized and its structure is a planar structure bearing a bond angle of 120 degree. There are more number of evidences showing that these carbocations are planar. Let us see about the stability of carbocations. When an electron releasing group like alkyl group which bears a plus I effect present near the carbon atom which bears the positive charge, that is a carbocation, it increases the stability of the carbocation. So here I have given three examples, that is first one is tertiary carbocation, second one is secondary carbocation and third one is primary carbocation, and I have given the order of stability also. In the tertiary carbocation, the carbocation C plus bears three alkyl groups. I have shown the arrow mark, that is these alkyl groups releases the electron towards the carbon atom bearing positive charge. Hence it is more stable than secondary carbocation which bears two alkyl groups, and it is more stable than primary carbocation which bears single methyl group or single alkyl group. And then next example I have given here, NO2CH2CH2 plus is less stable than propyl carbocation. Here in this propyl carbocation, CH2 plus is nearer to ethyl group which is a plus I group. So it releases the electron and it becomes stable. But in NO2 group is minus I effect. The NO2 group possesses minus I effect. That is, it withdraws the electron from the carbon chain. So it is less stable. And the next example is benzyl carbocation. The stability of carbocation is increased by the number of resonance structure increases. That is, here in the phenyl group there is one CH2 plus group. Here the resonance takes place and the benzyl carbocation forms 5 resonance structures or 5 canonical structure. Hence, when compared to the propyl carbocation or alkyl carbocations, the benzyl group is more stable, and also allyl carbocation is also stable than propyl carbocation. In this first diagram, I have given the allyl carbocation. That is, these allyl carbocation possess two canonical structures. That is, the double bond undergoes resonance and the plus charge is beared by another carbon atom. So, again if we give the order of increasing stability of carbocation, in benzyl carbocation is more stable than allyl carbocation than propyl carbocation. And the next example is triphenyl carbocation. In this there are 3 benzene group attached to the central carbon atom bearing positive charge. So it produces more number of canonical structures. So this is more stable than even when compared to the benzyl carbocation. Also, the carbocation is stabilized by conjugation of the double bonds. If more number of double bonds is present in the carbocation, because of delocalization, it also becomes more stable. I have given one example here. And then again, the carbocation is also stabilized by the presence of heteroatoms like oxygen, nitrogen and halogen, which is adjacent to the carbocation, that is C plus, carbon bearing plus charge. Here I have given one example. Methoxy group is attached to the carbon atom bearing positive charge. So it possesses two stable structures, that is two canonical forms. That is, the lone pair of electrons is shared by the carbon atom and then the oxygen takes plus charge. So it is also more stable. And then next example is cyclopropyl carbocation. When the methyl group or alkyl group in a carbocation is replaced by a cyclopropyl group, then the stability of carbocation increases. In the first example, that is in trimethyl carbocation, one methyl group is removed by one cyclopropyl group. And then in the second example, there is 2 cyclopropyl group, and in third example there is 3 cyclopropyl group. So here each addition of a cyclopropyl group increases the stability of the carbocation. So here the tricyclopropyl carbocation is more stable than the other two. Next we are going to see about generation of carbocations. First method, it is prepared from alkenes by addition of acid. In the next example, it is prepared from alkyl halides. When the alkyl halides is treated with a solvent, it undergoes reaction to produce a carbocation and a halogen anion. And in third example, diazonium ions are unstable one and it decomposes at room temperature to give carbocations. This nitrogen atom takes the bonded pair of electrons along with it to produce nitrogen gas and it gives a carbocation. And the next one, carbocations are prepared from the alcohol. When it is protonated, it forms first the protonated alcohol and a water molecule is removed and it gives a carbocation. And in next method, it is also prepared from acyl halides or COCl. That is, when the acyl halides is treated with the anhydrous aluminum chloride, it forms a complex first and then the AlCl3 takes off one chlorine atom from the acyl chloride and bears the negative charge and it becomes AlCl4 minus and then it forms acylium carbocation. And then we are going to see about reactions of carbocations. These reaction intermediates like carbocation, carbon ion, nitrenes, carbenes, everything is very reactive and is unstable. So it undergoes many reactions to give stable products. In this there are 4 reactions I am going to explain now. First one is elimination of a proton And the second one is reaction with the nucleophiles. Third one is addition to unsaturated compounds. Fourth one is molecular rearrangement. First example is elimination of a proton. For example, I have given propylamine. When this propylamine is treated with NaNO2 and HCl, it forms propyl diazonium cation. As we told already, this N atom takes along with it the paired electrons and it is removed as N2 and it forms propyl cation, carbocation. And these propyl carbocation, when it removes a proton, it forms a propene. Also, this propyl cation is a primary carbocation. Hence, it undergoes rearrangement reaction to form a stable secondary carbocation. That is, one hydrogen from the second carbon is rearranged to the carbon bearing plus charge and it gives secondary carbocation. Also, this secondary carbocation removes a proton to form propene. And the second reaction of carbocation is reaction with the nucleophiles. It reacts with the nucleophiles to form alkyl halides. For example, first I have given propyl carbocation reacts with the bromine ion to form N-propyl bromide. And then secondary propyl cation reacts with the chlorine to form isopropyl chloride. And then tertiary butyl carbocation reacts with the water, which is a neutral nucleophile, to form an intermediate, and then after the removal of proton it gives tertiary butyl alcohol. And the next reaction is a carbocation undergoes addition reaction with unsaturated compounds to form a bigger carbocation which have higher molecular weight. So here 2-methylpropene reacts with the tertiary butyl carbocation to form a new carbocation. Also, carbocations undergoes molecular rearrangement. In this first example we have seen in the previous slide, that is a primary carbocation which is unstable, it undergoes rearrangement to form a secondary carbocation. And then in the second example, this is 3,3 dimethyl 2-butyl carbocation, that is it is a secondary carbocation. Here the carbon bearing positive charge is secondary one, that is it consists of 2 alkyl groups and 1 hydrogen atom, and so it rearranges to form a tertiary carbocation. Thank you for watching my video. If you like this video, please press the like button and share this video and subscribe for our channel. In the next video, we will see about carbon ion. Bye.